Hello everyone. Today we are going to start integration part of a vector integral calculus. First thing we are going to learn is the arc length of a curve. Suppose C is any curve parameterized by variable t on in interval a to b, and Rt is a position vector of any point on the curve, which can be written as Rt is equal to xti ytj plus ztk. Then the arc length is given by S is equal to integration from a to b mod of r dash t dt, where r dash is nothing but x dash ti plus y dash tj plus z dash tk, and mod of r dash is equal to under root of x dash t whole square plus y dash t whole square plus z dash t whole square. Now using this formula, we are going to find the arc length. First illustration, find the arc length of the portion of circular helix. R bar is equal to cos ti plus sin tj plus tk from t is equal to 0 to t is equal to pi. Here we have rt is equal to cos ti sin tj tk, correct? So derivative of r with respect to t will be r dash t, that is minus sin ti plus cos tj plus 1 into k. So mod of r dash t will be under root of sin square plus cos square plus 1. That will be a root of 2, because sin square plus cos square has a value 1. So the arc length from 0 to pi is given by integration 0 to pi mod r dash t dt, that is 0 to pi root 2 into dt, that is root 2t, and limit is from 0 to pi, and that will give you the answer is equal to root 2 into pi. Same manner we are going to check second example. The shape of cable from an antenna tower is given by the equation y from the antenna tower is given by the equation y is equal to 4 by 3 x raised to 3 by 2. From x is equal to 0 to x is equal to 20. Find the total length of the cable. Here the shape of cable is given by y is equal to 4 by 3 x raised to 3 by 2. So r bar is equal to xi plus yj plus z. Since cable lies in 2 dimensions, that means it is in a plane, so z is equal to 0. Let x is equal to t, that will give y is equal to 4 by 3 t raised to 1 by t raised to 3 by 2. And therefore our position vector r bar is ti plus 4 by 3 t raised to 3 by 2 j plus 0 k. And therefore r dash will be 1 into I plus 4 by 3 into 3 by 2 raised to 1 by 2 j plus 0 into k. That is I plus 2 root t j plus 0 k. And that will give you mod of r dash t is equal to under root of 1 plus 4. Now using the formula of arc length, we have S is equal to integration 0 to 20 mod r dash t dt, but mod r dash is nothing but under root of 1 plus 4 t dt. Now integrating this, that will give you x raised to n plus 1 upon n plus 1, that means 1 plus 4t raised to 3 by 2 upon 3 by 2, and the coefficient of t 4 will be going to be in a division. So simplifying this one, putting limits, first putting 20 and then putting 0, that will give you the answer 364 by 3. Same manner, we are going to check third example. Find the arc length of the curve x is equal to t, y is equal to t square, z is equal to root 3t from t is equal to 1 to t is equal to 3. Here x is equal to t, y is equal to t square, and z is equal to root 3t. So r bar is equal to, therefore r bar is equal to xi plus yj plus zk is equal to ti plus t square j plus root 3 into tk. So r dash will be I plus 2tj plus root 3k. So r dash t is equal to under root of 1 plus 4t square plus 3. And that will give you under root of 4 plus 4t square. So 4 common out, that will give you 2 plus under root of 1 plus t square. And therefore, the arc length from t is equal to 1 to t is equal to 3 is s is equal to integration 1 to 3 mod r dash t dt. And that will give you t is equal to 1 to 3 r dash t is equal to 2 under root 1 plus t square dt. So that will give you 2 common out, integration of under root of a square plus x square is x upon x by 2, that means t by 2 under root 1 plus t square plus a square by 2, but a is 1, so it is 1 by 2 log of t plus under root of 1 plus t square. Substituting limits and simplifying, that will give you answer 3 root 10 plus log of 3 plus root 10 minus root 2 minus log of 1 plus root 2. This is a simple integration. Here we are finding the length of a curve. Now we are starting with a line integration. Now the line integration is a simple and the natural generalized form of integral is given by integration a to b fx dx, where fx is a function of x and we are integrating function from point x is equal to a to x is equal to b. This is your simple integration. Instead of that, in the light integration, we are going to integrate the given function along the curve C in the space or in a plane. Now it may happen that your curve is in a 2-dimension like figure 1 or figure 2, or it is in a 3-dimension as shown in a figure 3. So it is not necessary the given curve is always a 2D. Secondly, the integration requires that C must be a parameterizable. That means whatever the curve we have 1, 2, 3, they all must be written in a parametric form. That means the parameterization must be possible. Then only you can find the line integration. Because if your function is not going to be in a one variable form, then it is not integrable. So that is the position vector x must be written in the form of rt is equal to xti, ytj, ztk, where t is between a and b. Now a is equal to ra is called the initial point and b is equal to rb is called the terminal point. And c is now oriented curve. Oriented, that means the directed curve. Now you are moving from a to b or you are moving from b to a. It is very important. The direction is very important in a line integration. Now the direction from a to b in which t increases is called a positive direction. That means if you are taking integration where t is going to be increased from lower value to upper value, then only it is a positive direction. If you are going from upper value to lower value, then it is the negative direction. Here, if A and B are coincide, then the curve C is called a closed path, as we have shown in the figure 2. C is called a smooth curve if it has a tangent at each point which is continuously varies as we move along the curve C. That means in simple logic, R dash T is continuous at each point. Now we are starting with a line integration. A line integration over a vector function f bar r over a curve C r bar t is defined by f dot dr, integration over C f dot dr, or you can write it a to b f rt dot r dash t dt, where rt is a parametric representation of your curve C, which also can be written in a form of, since f bar is equal to f1i, f2j, f3k, and dr is dxi, dyj, dzk. So the dot product will be f1 dx plus f2 dy plus f3 dz. Same manner here, f1 dx by dt, f2 dy by dt, f3 dz by dt into dt. See here we have written this term in a form of variable t, so that's why we have written the limit from a to b. That means t is varies from a to b. But here we have not written it in any one variable form. That's why we are simply writing integration along C, or you can write the integration from capital A to capital B. Okay. Okay. And the last thing is, if our curve is a closed curve, then the integration is called a closed integration, and we are going to write the closed integration by this symbol, closed integration over a curve C. Now we are starting with the illustration. Find f dot dr. Now you have to find f dot dr, where when f bar is equal to minus yi minus xyj, and C is the circle in the first quadrant as shown in a figure. So here we have given a figure. Here we have given a circle in the first quadrant. See, from figure it is shown that it is obvious that one is radius 1 we have. Radius of a circle is 1. Secondly, you are integrating from A to B because direction is given. So at a point A and at a point B, we have to find the values of t. Now the equation of circle, unit circle in a parametric form is given by x is equal to cos t, y is equal to sin t. Now here it is simple, t is always starting from 0. That means if you are considering theta, then theta is starting from 0. If you are and then it is moving up to pi by 2. So t is moving from 0 to pi by 2. Secondly, r bar is equal to cos ti plus sin tj. Now z component is 0, so it is not necessary to write. Same manner, dr is equal to minus sin ti plus cos tj dt. Basically it is minus sin t dti cos t dtj, but I have common out dt, and that's why it is written in this form. Now f bar is equal to minus sin t into I minus sin t cos t into j. See, what we have written is f bar is your xi plus yj, where it is here minus y minus xy. Here we are putting y is equal to sin t and x is equal to cos t, correct? So now f bar, we have f bar, same manner we have dr, therefore f dot dr. So f dot dr, that means dot product of these two. So I component is multiplied, jj component is multiplied, and we have integration from 0 to pi by 2. See, you are integrating from 1 0 to 0 1. Now you have written it in a form of t. So now t is varies from 0 to pi by 2. So integration 0 to pi by 2 sin square t minus sin t into cos square t dt. Separating integration, so integration sin square t dt, integration from plus integration cos square t into minus sin t. I am going to take this minus inside the integration because this is the form of fx raised to n into f dash x. Okay, so sin square will be replaced with 1 minus cos 2t by 2 for integration, and here fx raised to n into f dash x as integration fx raised to n plus 1 upon n plus 1. So integrating this one, that will give you integration 0 to pi by 2, 1 minus cos 2t by 2 dt plus cos cube t by 3, 0 to pi by 2. So is equal to integration 1 by 2 common out, 1 has a integration t, cos has a integration sin 2t by 2. Here we are going to put the limit cos pi by 2 has a value 0, minus cos 0 has a value 1. So this will be 0 minus 1 by 3. Now here put the limit. So t is equal to pi by 2. So pi by 2 minus sin 2 pi by 2, that means sin pi. But sin pi has a value 0. Minus, if you are going to substitute 0, then t will be 0, sin 0 will be 0, so lower limit both has a value 0. So 1 by 2 into pi by 2, that will be pi by 4 minus 1 by 3. So this is your final answer. Final answer pi by 4 minus 1 by 3. Okay. So this is the simple line integration. We are going to check more examples in the next video.